Hi dear friends, how are you? I hope you and your family are doing well. Dear friends, in our previous lecture, we discussed about the nature of light. Dear friends, today we'll discuss about one of the mysterious principles in quantum mechanics known as Heisenberg's Uncertainty Principle. Dear friends, Heisenberg's Uncertainty Principle is a fundamental principle in quantum physics. It is one of the fundamental principles which led to the development of quantum mechanics. It was first introduced in 1927 by German physicist Werner Heisenberg. This principle is also known as the principle of indeterminacy principle. This principle is a direct consequence of the dual nature of matter. In quantum mechanics, a particle is described by a wave packet which represents and symbolizes all about particle and moves with group velocity. According to Bohr's probability interpretation, the particle may be found anywhere within the wave packet. It means that the position of the particle is uncertain within the limits of the wave packet. Moreover, the wave packet has a velocity spread and hence there is uncertainty about the velocity or momentum of the particle. That is, it is impossible to know where within the wave packet the particle is and what is its exact velocity or momentum. For a large wave packet with many crests, the velocity spread is very small, so that the particle velocity can be more accurately determined. But the position of the particle is very uncertain. On the other hand, for a small wave packet, the position of the particle can be more or less fixed, but the velocity spread of such a packet is very large, and the velocity of the particle becomes indeterminate or uncertain. If we consider infinitely large wave packet, the velocity of the particle becomes certain, but the position of the particle becomes completely uncertain. On the other hand, if we consider infinitely small wave packet, the position of the particle becomes certain, but the velocity of the particle becomes quite uncertain. Hence, it is impossible to determine simultaneously both the position and momentum or velocity of a particle with accuracy. According to this principle, the product of the uncertainties in position and the velocity is equal to or greater than a tiny physical quantity or constant h by 4 pi, where h is Planck's constant. If delta x is uncertainty in position and delta p is uncertainty in momentum, then delta x into delta p will always be greater or equal to h by 4 pi. That is, delta x into delta p is always greater or equal to h cross by 2, since h cross is equal to h by 2 pi. In the other generalized form, this principle is stated as the values of two canonically conjugate variables cannot be simultaneously measured with accuracy, that is, zero error, for a microscopic particle. The product of uncertainties in the simultaneous measurement of conjugate variables always has a value above or equal to a certain minimum h by 4 pi. Canonically conjugate physical quantities are those whose product has dimension of action, that is, joule second. Thus, if delta E is the uncertainty in determining the energy of the particle and delta T is uncertainty in determining the time to which this determination refers, then delta E into delta T will always be greater or equal to h cross by 2. And similarly, if delta J is the uncertainty in determining the angular momentum of the particle and delta theta is the uncertainty in determining the angle, then delta J into delta theta will always be greater or equal to h cross by 2. The uncertainty principle actually states a fundamental property of quantum system and is not a statement about observational success of current technology. Dear friends, Heisenberg Uncertainty Principle is not about the error in measuring by technological errors. It is about the fundamental principle which exists in the nature. It is the principle of nature, the product of two canonically conjugate variables will always be greater or equal to h cross by 2. This is the principle of Heisenberg Uncertainty Principle. I hope, dear friends, you have understand this principle, the principle of Heisenberg Uncertainty. Dear friends, I would like to thanks to you for watching the video by spending your valuable time. I request, please like, subscribe and share the channel so that you will get more notification for our further lectures.